All right, SAS geometry students, welcome to screencasting. All right, we're going to use this for things such as constructions. This first video is about constructions. Uh, Things that are maybe some GSP stuff, things that you need to be able to know how to do that require some explanations that's kind of just hard to write down. It's easier just to demonstrate for you. So this is our first demonstration. Today we're going to be doing three constructions. These are the constructions that are in the Unit 1 content. These will be possibly on your test at the end of Unit 1. First one is how to copy a segment. And yes, these are your construction tools. You need a compass and a straight edge. Okay, so I'm supposed to make a copy of this. I can use the straight edge however I want. To make straight edges of things. How can I? Yeah, okay. You can slap this ruler down any direction you want. You can make a straight line. Sometimes this is harder than actual real tools in real life. Make your line so you're sure that it's longer than the segment you're trying to copy. This line can be as long as you need it to be. Straight edges are allowed for making lines. Basically, that's it. I just need to make a segment on that that's exactly this long. Now, I can't use the marks on the ruler. I need to be able to see in your work that you didn't use the marks on the ruler. All right, so I need to pick a point that's on my line that's going to correspond with A. I'll call it A. Oh, why don't I call it A prime? I'll be fancy. I can't use the ruler to measure, but I can use the compass to measure. I can use this compass, and I can figure out how long AB is simply by using the compass like a little tool like this, a little bit off of my point A. So I just put one on one end, put the pencil on the other end until I'm sure it's the right length. Some teachers like you to do this so you can kind of make sure you've shown that so you can show that it's the same. And then I'm going to stab, I'm going to basically take this length and I'm going to move it down here and copy it onto this line. And there we go. So I've just basically taken this span, and I've left the span the same. I measured the span of it over on the AB segment, and I brought it over here, and that's allowable with the compass. So, and by showing this nice arc here, the reader can tell that I've spanned here and I've copied the span over there. So now there's my answer. I'll highlight the answer. So I don't know, maybe that looks kind of nice. This is the thing that's really the answer. That's the segment there that I've created that's the same length as AB. All right, next one is how do I copy an angle? First of all, get your tool out of the way. I don't know if I have enough room to do this. Oh, I think I probably will. Start out by making any old, I'm going to make an AC, but my new AC is going to be kind of down here somewhere. And it kind of looks parallel. It kind of makes it easier to predict what's supposed to happen when you make it look sort of parallel. So I'm making array AC, and I don't care about the length of this, of course. The length from A to C doesn't have to be the same as the length from A prime to C prime. I don't really care about that so much. What I'm really concerned about copying is the size of this angle exactly. So I'm starting out with array AC there. And really, then my only task is to figure out exactly where in the page to put this kind of array that's going to go here so that it's going to end up with the same angle size as this one. Alright, it's a little bit trickier than the last one. I stab, a lot of times when we're dealing with angles, we stab at the corner on the angle, so that's kind of predictable. I stab there, draw an arc across both parts of this angle here. You'll see why in a second. Of course, later in the year, you're going to go back and prove why this is, so it's good to be able to do. In fact, this is just awesome anyway. These are great party tricks. You can bring out these at math parties, and people will be so impressed that you know how to do this. Okay, so I've made a similar arc, actually congruent arc. Stab, rainbow, same span, stab, rainbow. I kept the same size compass here and here. So I have so far the picture is the same. All right, I'm still trying to locate, of course, where this little B goes here. But with this radius now the same as this one, sort of the size of the jaws on this thing, like the distance from that to that, I just really want to know how long that is. How wide open is this mouth at when it's a rainbow that's exactly this far from the center. When I know that, actually I should probably do this the other way around. That would have worked, but it's gonna look better if I do it this way. Let me stab it this way. If I stab that one and see it's the same. Stab it there and measure here because then it's gonna feel more like what I'm doing down here. Stab there and cross the first arc with this arc. That tells me that ray has to go through there. So my ray AB connects that dot with the little crosshairs I just made. Turning this ruler is not as easy as it is on real paper. Something like that. draw that line. Okay, so my B is, now you don't really need the point B. I could have called that B, it's okay. B is not the location, exact location of B on the ray isn't such a big deal. My answer now really is I have located and created this angle. This angle that I just made here is the same size as the original ABC. All right, we got one left. I'm going to give you an angle. Oh, it's hard to see. Let me fix that just a second. Sorry, that's better. I didn't realize I was going to make that go off the page. Okay, so now I have angle ABC that's printed there. Oh, by the way, you can kind of tell when you go back and look at these later, or if you look at a static version, because I'll make that available too. I left it so that the black stuff is the stuff that was the printed problem, like on your test. The black thing is the printed thing. The red is sort of my work. And then you don't have to highlight the yellow answer. I'm just kind of indicating for you. That's the answer to the question. The actual thing on here that is the segment that's copied or the angle that's copied, those are the things in yellow. All right, so here we're at this construct the bisector of angle ABC. All right, just sort of estimate what that's going to look like. We're looking for this kind of ray that's going to come out of B, and it's going to go right exactly halfway through the middle of this angle, so that the top part and the bottom part are exactly equal. So it's an angle bisector. Okay, this you might have guessed. Set your compass so that it's, I don't know, comfortably big, and stab down here at the vertex B and drag a little rainbow across your angle. Make sure it crosses both here and here, because now we're going to take the compass and stab here where that intersects one ray, make an arc, and stab here on the other ray. Whoops, I moved my stab. And make an arc. And where those intersect is, guess what? The place I draw my line. Okay, how do I get this to turn? Whoa, that's kind of unpredictable. All right. Real rulers are easier to aim than this one. Okay, is that about right? If I just get that? Yeah, I'm going to say that's going through both points. Let's just leave it there. And ta-da! It's a little bit off, but that was just ruler aim. This thing I'm claiming now, we could talk about why in class, but this thing I'm claiming is the bisector of that angle. I left my span the same on all these arcs. It's not terribly important that the span on the first one is the same as these two. These two definitely have to be the same, though. When you make that arc and when you make this arc, which are stabbed from here and here. Of course, you don't have to draw all this stuff. Those two have to be the same. This first one can be a different size, but later when you do these, you stab here, make an arc, stab here, make an arc. Make sure you don't change the compass size. Okay, that's about it. Pause and rewind if you need to see that again, and we'll see you in class.